In this review video, I'm going to go over ionic and covalent and the basic properties. And then the next video, we'll go over how to name and formula write them. So when you are looking at this periodic table, in order to identify if it is ionic, you have to know where your metals are at. So metals are anywhere to the left of this staircase right here, except hydrogen. These are all your metals. In order for it to be ionic, there has to be a metal in the formula. The other part of the formula will be made up of a nonmetal, which is anything to the right of that staircase, including hydrogen. An ionic will have one of each, sometimes more than one nonmetal, but it has to have a metal. It has to have a metal for it to be ionic. Some characteristics of ionics, on top of it having a metal and a nonmetal, is that there is a transfer of electrons. Now in class, we showed this by drawing our Lewis dot or our E dot for it. You're not tested on drawing it, but I'm just showing this as a visual. Na is in group 1A, so it had one valence. Cl is in 7A, so it has 7 valence. And then we drew that this Na would give away an electron to Cl, and when it did that, Na would have a positive 1 charge and Cl would have a negative 1 charge. This transfer of electrons causes the positive and the negatives, which allows these two ions to be attracted to each other because opposites attract. You need to remember that metals lose electrons. Electrons are negative, so when metals lose, they become positively charged. They have that positive charge. They're losing something negative. Just like if I were to lose my negativity, I would become a more positive person. The metals are losing something that's negative and becoming positive. The vocab term for this is cation. All of your metals do this. All of this area right here do this. Everything in this area will have a positive charge and will be a cation. The nonmetals always gain the electron. So Cl is modeling this for you. Nonmetals gain electrons. When they gain electrons, they're gaining something negative. So they're going to become negative and have that negative charge. These are called anions. One quick way to remember the difference is that cation has that positive T looking in there, so it has a positive charge. Anion looks like an onion. When you cut an onion, it can make you cry. That's negative. So these are the characteristics of ionics that you need to know. You also need to remember it has to have an overall charge of 0. This is important. This is how we write our formulas for ionic. Now for covalent, I'm going to be very quick about this one because there's not as much to it. For a covalent, it's 2 or more nonmetals. There are no metals in covalent. Because there's no metals in covalent, there's nothing giving away electrons. So they don't give away, they don't share, they don't transfer, they share electrons. Sometimes they'll share it equally, sometimes they'll share it unequally, but the key thing is that they're sharing. So there's nothing losing, there's nothing gaining, therefore there's nothing with a full positive and a full negative charge. We also don't have to worry about an overall charge, but because they're sharing, they can combine in a lot of different ways. So you could see something that looks like CH2, you could see CH4, you could see C with an O and CO2, so there's not one fixed ratio. This side has a fixed ratio because of this overall charge of 0. These guys can combine in a whole lot of different ways. So when you're naming these, you have to use those prefixes, and I'll get into those in the next video. These are the two main things as far as properties that you're going to be tested on with covalent, is that it's 2 nonmetals, which means they come from this area. and that they share electrons.